And so if you could see that the scrolling on the standard Android browser is pretty, pretty kind of choppy, but the scrolling here is much smoother, right? And the reason for that is, so you can just, see the clear difference there. The reason for that is this is just a standard, not hardware accelerated, and this actually uses a backing store that's hardware accelerated for the Adreno GPU. So it's a way of how we're actually using the hardware on the Snapdragon, but modifying the browsing system to take advantage of that, right? Another thing that we've been working a lot on is JavaScript performance. And again, here what we're doing, let me start these both at the same time. What you're looking at is for each tile you're actually running one of the SunSpider tests.
Oh, nice.
So this is actually the SunSpider benchmark visualized is the best way to say it. And you can see that how the SunSpider benchmarks are running much faster in the optimized device than the unoptimized. And what the optimization here is that we contribute to the V8 project. So actually, or even here it includes our work, but we're further optimizing the V8 JavaScript engine for the CPU core inside the Snapdragon. Because obviously the microarchitecture of our CPU core is different than a Cortex A8 or A9. And so, we talk a lot about the fact that the Snapdragon is not just an integrated system, but it has this low power or higher frequency CPU core. That's great, right? To me, that's a foundation to actually exploit things much better, to take the browser, take the JavaScript engine, and actually tune it, not just for ARM, but for our, our CPU core. This is the result of all that investment, right? At the end of the day, and of course, this affects not only page download time, because JavaScript execution is about 25% usually, 25 to 30%, but it also affects how powerful web apps are going to be, right? How powerful web apps can be. Another example that we have here is the capability that we brought into market to actually have full in-page HTML5 video right in the browser. And so what you're looking at here is, as you can see, full HTML in-page video, right in the browser. And you're looking at multi-instances. They're all running. Those are all HTML5 video tag videos. We made up a SurfTube web page, obviously.
Nice. Are these H.264? Or?
These are H.264 in an HTML5 MP4 container.
Are you going to have VP8 support or WebM?
Some of our hardware has VP8 support, but it's and that's an orthogonal type of thing. So this is specifically, it's hardware accelerated for H.264. I don't think we have VP8 support in any chips in hardware accelerated. So in the standard Android media player, if you have a HTML5 video tag playback, it actually pops out and goes to the media player. But here you can see that it's actually right in the browser, just like your desktop level experience, as well as, and I can switch these around, this is going to flip between that and that, but as well as multiple videos, concurrent videos, all hardware accelerated, playing at the same time. So pretty good example of some of the rendering work that we're also doing here. Let me also show you what Paul referred to is something that we've been showing just very recently about support for full 1080p flash playback right in the browser itself. So what we have here loaded is a HD weather website that we made up, and this is actually kicks off the flash player that you can see there. And I'm going to double tap there, and you can see here this is full 1080p flash playback, playing back at about 24, 23 frames per second, right?
Very nice.
And it's actually again right in the browser itself. And of course, that's now then after decoded, scaled down to wide VGA on the screen. But you could actually go HDMI out, of course, right to a large screen. So, not only is 720p something that we've been doing very kind of smoothly and using hardware acceleration, but also flash video at 1080p, true HD.